Hi everybody, I hope you are doing well. And today we will go deeper into the polar and non-polar bonding, which is defined by the electronegativity. Okay, so in this video, I will talk about electronegativity and the type of bonding. And at the end of the video, I will talk about the trend of electronegativity in the periodic table. So that's why I prefer to postpone the trend of electronegativity after explaining what is electronegativity. So what is electronegativity? Electronegativity is defined as the power of an atom to attract a pair of electrons when it is involved in a bond. So if we have a bond, especially a covalent bond, depends on sharing pair or more of electrons between two atoms. For example, the HCl. HCl has a covalent bond between hydrogen and the chlorine. And if you remember from the video of the covalent bond, I mentioned that chlorine needs an extra 1 electron to have its outer shell full. And hydrogen needs also an extra 1 electron to have its outer shell full. So chlorine and hydrogen each will share a pair of electrons together, one from chlorine and one from hydrogen. Sharing means each atom will take these 2 electrons for some time, and then the other one will take these 2 electrons for some time. Whether they will attract the pair or share the pair of electrons equally or unequally, this depends on what is called electronegativity. Which atom can attract, has more power to attract electrons, will share or take this pair of electrons for more time than the other. So the electronegativity is the power to attract this pair of electrons. So the electronegativity is defined as a number from 0 to 4. So atoms have electronegativity value, which is from 0 to 4. For example, hydrogen has an electronegativity of 2.2, while chlorine has an electronegativity of 3 or 3.1. Anyway, chlorine has more value of electronegativity, which means chlorine has more power to attract electrons. So chlorine will take the pair of electrons for a longer time than H will do. That will give chlorine a partial negative charge, which represented as delta negative. So chlorine will carry partial negative charge. The higher electronegativity, the atom with the higher electronegativity will have partial negative charge, while the atom with the lower electronegativity will have a partial positive charge. It is not a pure negative charge or a pure positive charge. It's partially negative and the other atom is partially positive. So the partially negative atom is the atom that can take the electron for more time than the other atom, which is less electronegative. Okay? Also, it can be explained as an arrow going from the less electronegative atom to the more electronegative atom. And at the beginning of the arrow, we make like a line representing that this is the partial positive portion of the bond. Okay, so it can be represented at that in this way or in this way. Okay, so the more electronegative atom will carry a partial negative charge, which is represented in that symbol, and the lower electronegative atom will carry a partial positive charge. Okay, so in that case, the pair of electron is not shared equally between the two atoms because one atom is stronger than the other, has more ability to attract this pair of electron. Okay, so in that case, this is called a polar covalent bond. Okay, if we have another example, such as Cl2, so Cl is bound to another Cl and they share a pair of electrons, one from each atom. So the first Cl has 3, an electronegativity value of 3, and the other one is 3, 2. Okay, so they have the same electronegativity, so no one is stronger than the other. Both atoms, because they are the same atoms, will share the pair of electrons equally. Okay, and in that case, this is a non-polar covalent bond or a pure covalent bond, or we can name it true covalent bond. There is no polarity, but here there is polar. There are two poles. One pole is partially negative and the other pole is partially positive. Okay, this is the idea of electronegativity. Delta N, delta En, which is electronegativity difference, is the difference between the electronegativity value of the two atoms that are bind together. If we consider the first example, which is HCl, okay, H has an electronegativity of 2.2 and the chlorine has an electronegativity of 3. So the electronegativity difference is the subtraction of the two values. So 3 minus 2.2 equals 0.8. And this is the electronegativity difference in HCl. H2 has a bond between the two H atoms, and every H atom has a polarity, has an electronegativity of 2.2. So electronegativity difference is 0. Two point two minus 2.2 equals 0. And when the delta electronegativity or the electronegativity difference is 0, it means that they share the pair of electron equally, and this bond is pure covalent bond, while the other value, the value that is other than 0, means that there is an unequal share between the pair of electrons. So it will be a polar covalent or an ionic, depending on the value of the electronegativity difference, which means the type of bond can be classified according to the electronegativity difference. The types of bonding can be explained depending on the electronegativity difference value. In that way, so if the electronegativity difference between 0 and 1.7, it's covalent. If it is more than 1.7, from 1.7 to 4, it's ionic bond. So more than 1.7, it's ionic, it's a very high electronegativity, and less than 1.7 is covalent. But covalent can be non-polar or slightly polar or polar covalent, depending on the value of the electronegativity difference. So if the value of the electronegativity difference is 0, it means that this is a non-polar covalent bond, or it's pure or true covalent bond. If the value is less than 0.5, so more than 0 and less than 0.5, it's slightly polar covalent bond. So it's not true polar, but it's have slight polarity. More than 0.5 to 1.7, it's a true polar covalent bond. And as mentioned, more than 1.7 is ionic bond. So we can represent the polarity starting from 0 and ending with 4, because electronegativity is a value between 0 and 4. And here is 2, the middle. And 1.7 is a critical point, because below this value, it's covalent bonding, and above this value is ionic bonding. So from here, it's ionic bonding. And here from 0 to 0.7, it's a covalent bonding. At 0.5, is a critical point between polar and nonpolar covalent bond. So 0 is pure covalent. Between 0 to 0.5, it's covalent, true covalent, but it has some polarity, slightly polar. Between 0.5 to 1.7 is polar, true polar covalent bonding. We can classify the types of bonding depending on the electronegativity difference between the two atoms on the same bond. This table has examples of atoms with their electronegativity values. So we can use it to solve many examples and to classify the bond according to the electronegativity difference. Some examples, Cl2. We need to know what is the type of bonding of each of these compounds or molecules. Cl2 molecule, it's a Cl-Cl bond. The Cl from the table, it's 3.16 or 3.2, 3.16, and of course the other Cl will have the same value, 3.16. Then the electronegativity difference equals the electronegativity of the first atom minus the electronegativity of the second atom. And the value is 0, and 0 on our grade is pure covalent bond. So this Cl2 is a pure covalent, bond, or non-polar covalent bond. HCl we did it before. H is 2.2 and Cl is 3.16. 1.6 or 3.2. So the electronegativity difference is subtracting 3.16 from 2.2, which will be around 0.9. And 0.9 is between 0.5 and 1.7. So this is a polar covalent bond. The other example, it's actually a bond between, this is NH3. There is a mistake, NH3. NH3. It's it's actually an NH bond. And nitrogen has an electronegativity of 3.04 or 3, you can consider it 3. And the hydrogen is 2.2. Then the electronegativity difference will be 3.404 minus 2.2. The value will be 0.74 or 0.8. So this is also between 0.5 and 1.7. So it will be polar covalent bond too. Let's have another example, such as NaCl. Which is NaCl bond. The electronegativity of sodium is 0.93 and of chlorine is 3.16. The electronegativity difference equals 3.16 minus 0.93. This will equal to 2.23, which is more than 1.7. So this is an ionic bond. Anyway, if you are asked to classify the bond according to the electronegativity, so you will just need to subtract the values, the electronegativity of each atom from the other, and depending on the number, you will know what is the type of the bond. These are other compounds which need to classify their bonds according to the electronegativity. I will leave you this to try them, okay? And to write down in the comments down below your answer and the type of the bond of each compound. Try to take a screenshot to answer them. So now we know what is electronegativity and how we classify the bonding according to the electronegativity of the atoms. So what is the trend of the electronegativity and why? As you know, we need to know what is the trend and why this trend, why this happens. So as defined before, the electronegativity is the ability of the power of an atom to attract, the ability to attract electrons, a pair of electrons. And when the atom is smaller, means that the nucleus is close to the outer shell. Which means that there is more attraction force. So the positive charge is attracting the negative charge, so it will have more ability to attract electrons. So at the atom becomes smaller as it has more electronegativity. While if the atom is larger, then the nucleus will be further from the outer shell electrons. And the attraction force will decrease. As being closer to the nucleus, to the positive ion, it will be easier to attract the electrons than when the atom is larger. Which means that attraction force increases in that way as become closer to the nucleus. As the outer shell is far from the nucleus, the attraction force is less, and the ability to attract electrons is less, and then the electronegativity is less. The electronegativity is higher in the smaller atoms than that of the larger atoms, and the reason is because the attraction between the nucleus and the electrons in the outermost shell is more in the smaller atom and less the attraction force less in the larger atoms. As the radius increases, the attraction force between the nucleus and the outermost shell electrons decrease. It's inversely proportional to the atomic radius. Depending on that, we can expect what will be the trend. So in the direction where the atoms become smaller, we expect that the electronegativity will become higher. Fluorine is the most electronegative atom. Why? Because if you remember, the radius decreases in that way. From right to left, the radius decreases. And from top to bottom, the radius increases. And in this way, electronegativity will increase too as the atom becomes smaller. The fluorine is the smallest atom over the first period. And going up from bottom to top, the electronegativity increase too, because in that way the radius increase. Because down from top to down, radius increases. So from bottom to top, the radius will increase. So as the atom becomes smaller, as the attraction force becomes stronger, which means higher electronegativity. And in short, as going toward fluorine, as the electronegativity increases, as going towards fluorine, the electronegativity increases. We expect that the last group, which is the noble gases, will not share in this trend because they are already full. The outermost shell is full, so it has no ability to attract more electrons or lose electrons.